All right. Well, hopefully everybody did really well with the number line, colored counters, absolute value, opposite, negatives, all that good stuff. And so now we're ready to move on to addition and subtraction of integers. And so again, what we're going to do is we're going to use two different techniques to talk about this. So we're going to use the colored counters and the number line. So again, in this section, sometimes we'll have to get a little bit creative, again, when it comes to either adding or subtracting, depending on whether we need to rewrite numbers in a certain way. So kind of keep that in mind. So the main thing we want to do is just make sure that we are, we're going to approach this from sort of a set theory model. So just like we did before. So in this case, what I want to do is I want to add 4 and negative 3. So what I'm going to do is I'm going to draw one circle that has 4 black dots in it because it's positive 4. And to that, I'm basically adding negative 3. So that means I'm going to make a circle with 3 red dots in it to represent the negatives. And then what we're doing is really doing a union of sets. So both of these guys are disjoint sets. So that means we can just add them together and make one big set. Whoops, let me do this in black. So what I'm going to do is I'm going to put my 4 black dots in there, and then I'm going to put my 3 red dots in there. And now I'm going to do what I talked about before by basically doing the zeros to figure out, what stays and what goes. So again, since I've got this black and this red, that means that's the same as the 0, so that's just going to go away. I've got this black and this red, so again, that's the same as a 0, so it's just going to go away. I've got this black and this red, which is the same, so that means they're just going to be 0. So in the end, all I have left over is one black dot. So my final answer would just be positive 1 in that case to represent that one black dot. So again, that's kind of all we're doing with these guys. We want to treat them as sets, union them together, and then do any kind of zeroing out if possible, just to figure out what our final answer is going to be. So again, let me look at part B here. So negative 5 plus negative 2. So again, let me first draw my 2 separate sets here. So in this case, negative 5 means I want 5 red dots. Negative 2 means I want 2 red dots. And so again, I'm adding them. So that means I want to combine them together into a big set. So let me bring my first 5 over. And then bring the other 2 over. So now in this case, notice there's no black dots anywhere. So there's no blacks and reds to cancel out. So all we have left over is just reds. And so if I count, I've got 1, 2, 3, 4, 5, 6, 7. So I have 7. Oops, I didn't want that. So 7 reds, which is going to be the same thing as the number negative 7 in this case. So again, it's kind of a cool way to represent addition, and you could start doing this with fairly young kids to introduce the idea of positives and negatives, which is kind of a neat way to do this. All right, so let's look at the next one, 6 plus negative 2. So again, let me first start off by writing my sets down. So positive 6 means I want to have 6 black dots in the first set. Negative 2 means I want to have 2 red dots in the second set. And so again, union these guys together. So that just means bring them all into one big circle. So I've got 1, 2, 3, 4, 5, 6. And then bring my 2 reds over. I'm going to write them there. And so again, now that we've got reds and blacks, we want to go ahead and get rid of, zero out any of those pairs that we've got. So in this case, I can take this red and this black, zero those out. Take this red and that black, zero those out. And so if I look, all I'm left with are 4 black tokens. So that tells me that my answer in that case would be just positive 4. All right, does this make sense to everybody so far? All right, perfect. So now let's go ahead and do the last one here real quick. So again, let me start off by drawing my sets. So I've got 4 black, or 4 positives, so that's going to be 4 blacks in the first circle. -7, which means I need 7 reds in the second circle. And so again, I want to combine these guys together into a single set. So let me bring my 4 blacks over first, and now bring my 7 red. And you can line these up anyway. As you notice, I'm trying to go ahead and pair my black and red ones up as I go along just to make life a little bit easier, but you don't have to do it that way. You can write it other ways. So again, in this case, since I've got both black and red, so again, I want to zero out any of them that I can. So I can pair that black and red to make a 0. Compare that one to make a 0. Pair that one to make a 0. Pair that one to make a 0. And so all that's left are 3 red tokens, which means my answer would be a -3 in that case. All right, perfect. So pause the video at this point. So I want you guys to do practice 1 the exact same way. So again, draw out your sets, union them together, combine them into one big circle, pair up any blacks and reds to get, zero out as many things as you possibly can. And then when you're done, come on back and then we'll talk about additions with number lines in this case. All right, so how did everybody do with colored counters? Was that okay? All right, perfect. So with adding with a number line, and so again, we did this with whole numbers for the most part, except we pretty much always went one direction. So in this case, because of having negatives and positives, sometimes we might go right, sometimes we may go left. So the sign of the number is going to depend on which way our arrows are going to go in this case. So in this case, I'm trying to add 4 plus -7. So let me put my 0 somewhere. Let me put it in the middle, I think, just to see. So 1, 2, 3, 4, 6, 7, -1, -2, -3, -4, -7. So that looks good. And so in this case, we're not using the point method. We're definitely using the arrow method to represent our addition. So in this case, we're going to plot the first number first. So +4 means we're going to start at 0 and jump 4 to the right. So in this case, this is our jump of 4. And so now in this case, we're adding -7. So what that means is I want to start at 4, but since I'm adding a negative, that means I'm actually going to jump 7 units to the left. So in this case, I'm going to go, 1, 2, 3, 4, 5, 6, 7. So I want to land back here at -3. So this is plus -7 in this case. So wherever our last arrow ends in an addition is always going to be our answer in this case. And so again, notice that our arrows always kind of like we've got the arrow of the first and the tail of the other one always meet. So subtraction kind of works the opposite of that, and I'll show you when we get to that. All right, so let's look at -5 plus -2 in this case. So again, in this case, I think I can still start with 0 in the middle. All right, so in this case, I want to start again with -5, but since -5 is negative, then I'm going to start at 0, and I'm going to jump the whole way to -5. And then to -5, what we're doing is adding a -2. So my next jump, again, I want to start at -5, but since I'm adding a -2, then that means I want to keep going left. So in this case, I want to jump 2 more to the left. So in this case, I'm adding -2 to that. And so again, wherever I land is going to be my final answer. So in this case, -5 plus -2 would be the same thing as -7. All right, does that make sense to everybody? All right, hopefully so. So if so, then you guys can pause the video at this point, jump in, work on practice 2. So again, there's a bunch of different kinds here. So again, start with the first number, and if it's positive, you'll go right. If it's negative, you'll go left. And then again, use the sign of the next number to determine whether you're going to go right or left. So that's kind of the nice thing about addition. The signs of the numbers always tell us which direction we're going to go, which makes life kind of easy. But if you get stuck on any of these, definitely let me know. Otherwise, when you're done, come on back and we'll look at subtraction with colored counters. All right, so back to subtraction here. So in this case, so again, we're using a similar idea to what we did with addition, but in this case, we're going to pair kind of using that set model with the takeaway method where we kind of pull stuff away. So this is the section where sometimes we have to get pretty creative with how we're going to actually write things so that we can actually get the numbers that we want. So this comes up on the very first problem. So let me show you what I mean. So in this first problem, we want to take 8 minus -3. And so in this case, what I want to do is I want to first draw my first number. So you always start with the first number, which is 8. And so I want to represent 8, since it's positive, with 8 black dots. 5, 6, 7, 8. All right, so there's my 8 black dots. And then using the takeaway method, what I want to do is I want to remove 3 red tokens from that circle. Well, hold on a second. I don't have 3 red circles that are actually in that token, so or that set. So how in the world can I take 3 red tokens away when there aren't 3 red tokens there? Well, I guess we just quit and give up, right? No, we don't quit and give up. So now we just have to write it a little bit differently. So this is where having to write 8 a different way comes in handy. So the idea is I know I want to take away 3 of these red tokens. So that means I need to introduce 3 red tokens to the set. So I'm going to put them down here so they're out of the way. But again, I can't change the structure of the circle. So it still has to contain just 8 elements on the inside overall, or 8 total elements when you add stuff out. So since I've added 3 red, I have to add 3 black to zero out those 3 reds that we added. So if I look, technically this number inside still represents positive 8, because these bottom ones, these down here, are really just 0. They're not really contributing anything, but it's going to allow me to do the arithmetic that I want to do. Whoops, didn't mean to get rid of all the dots. So now that I've got those 3 reds in there, now I can really do the takeaway method and say, okay, well, let's remove these 3 reds from the circle. So I can circle these guys and just kind of pull them to the outside, and now they're gone. And so what's left over on the inside is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I've got 11 black tokens left, which means my answer to 8 minus -3 is positive 11 in this case. So again, that's going to be the key to this problem is, sometimes we're going to have to add stuff in. Sometimes we're going to have to, to get the number that we want to be able to do what we need. So just kind of keep that in mind. We usually don't have to do that with addition, but subtraction, this comes up all the time. All right, so let's look at part B here. So again, -5 minus -7. So again, let's start off with our big circle, and we want to have 5 red circles, 5 red dots in there to represent our -5. So I've done that. And now the goal is I'm trying to remove 7 red tokens. Well, in this case, I've got 5, but I don't have 7 that I can actually take away. So again, I'm going to have to actually introduce some more red tokens so I can actually have enough to remove. So in this case, since I've got 1, 2, 3, 4, 5, that means if I want to take away 7, I need to add 2 more red tokens to this circle. But again, I can't just add 2 red tokens without pairing it with 2 black tokens to make sure that my overall circle still just equals -5. So again, we're kind of like what's called cleverly adding a 0 into these problems to make it do what we want it to do. All right, so now that I've got my 7 red circles in there, now I can use my takeaway method again. Grab these 7 red circles, pull them to the outside, and they just cancel out. And so lo and behold, what am I left with on the inside? I've got 2 black tokens left, which means my final answer is a +2 in this case. All right. Everybody okay with this so far? All right, perfect. All right, so let's look at part C here real quick. So again, same idea, start off with our big circle. Since we start off with -6 first, let's draw our 6 dots, red dots. Let's see, so we got 1, 2, 3, 4, 5, 6. Oops, I got 7 in there. Let's see. 1, 2, 3, 4, 5, 6. Yeah, it's 7. Sorry. And so in this case, we're trying to subtract. We want to take away 2 reds. So do I have 2 reds in there to actually take away? Yeah. So in this case, I don't have to do anything fancy because I've already got 2 reds in there. So I don't have to actually add in any reds. I don't have to add in any blacks or anything like that. I can just go straight to the takeaway method and say, okay, well, those 2, I'm going to pull to the outside. They're gone. So again, this leaves me 1, 2, 3, 4 red tokens inside my circle. So that means my final answer to -6 minus -2 would just be -4 in this case. All right, is that okay with everybody? All right, perfect. So finally, last one here for this problem. So -9 minus 4. So again, let's start off with our big circle. We've got to have 9 red tokens in there to begin with. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's my 9 red tokens giving me -9. And so from this, I want to subtract, I want to take away 4 positive. So in this case, so it's not explicitly written there, but remember when 4 is written by itself, it means +4. So that means I need to remove 4 black tokens. So I need to remove 4 black tokens. But again, just like part A, I didn't have any of those tokens. Same here, I don't have 4 black tokens in there. So I need to put 4 black tokens in there so I can actually remove them. So in this case, I'm going to put in my 4 black tokens. But again, I need to make sure that the inside of the circle adds up to -9. So that means at the same time, I want to add 4 red circles so that this bottom set of circles just equals 0 in this case. So now that I've got my 4 black tokens in there, I can actually use the takeaway method to remove them. So I can circle the 4 black tokens, pull them to the outside, and then again, that'll allow me to cancel those guys out. And then finally, what's left inside, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I've got 13 red tokens remaining. So that means my final answer would be -13 in this case. All right, does that make sense, everybody? All right, perfect. So again, pause the video at this point. Work on practice 3. So again, same kind of idea that we were doing before. So again, just be careful. Sometimes you may have to add counters in. Sometimes you may not have to, depending on how it's laid out and stuff like that. So, but again, for this one, you should only need 1 circle as opposed to the addition where we needed multiple circles, 1 for each number and stuff. So when you're done with that, come on back and then we'll talk about number line subtraction. All right, so let's look at subtracting with a number line. And so again, we did this with whole numbers, But again, I think this is going to make a little bit more sense when we do it with integers. And so the main thing to remember in this case is even though we're actually going to subtract, we actually want to think of this more as an addition problem. So what we're really doing is we want to treat these as a missing add-in problem. So instead of trying to subtract and get our answer, we're actually going to try to kind of work backwards as kind of an addition problem. So the way we want to think of this, so instead of like if they gave me 6 minus 2, instead of thinking of it as 6 minus 2, what if instead I try to say, well, what number added to 2 will give me 6? And the reason this is going to make more sense is because remember when we're talking about subtraction, in reality the two arrows should actually meet and the tails are actually going to be the answers in this case, as opposed to where a tail, an arrow tip meets the tail for an addition. For subtraction, the two arrowheads are supposed to actually be at the same spot. So what we want to do is kind of first draw our answer, which is always going to be the first number, and then try to figure out, well, what two numbers will add up to give me this correct answer. So let me draw it out because it'll probably make more sense instead of me talking about it. So again, let me start off with numbering my number line here. So I get 0, 1, 2, 3, 4, 5, 6, 7, -1, -2, -3, -4, -5, -6, -7. And so in this case, I want to find 6 minus 2, or in other words, what number added to 2 will give me 6. So in this case, what I want to do is first draw the answer. So I know my answer that I want is 6. So I'm going to make a big arrow from 0 to 6 in this case. And so the idea is the 2 is actually going to go, let me draw it in red, backwards. So the 2 is going to go like this. Because we know, whoops, I don't want an arrow there. Because we know something plus 2 gives us 6 in this case. So what do I need to draw? What jump do I need to make in order to actually get my final answer? So in this case, what I'm looking for, let me do it in purple or something, or blue, I guess. So what I'm looking for, here's my missing add-in that I'm looking for in this case. So I'm looking for the blue, which is going to actually take 4 plus 2 and give me my final answer. So in this case, the thing I'm looking for is actually that 4. So that's why our subtraction kind of looks the way it does, because we're really thinking of it as an addition and trying to find that missing add-in that's going to give us the answer that we're actually looking for in this case. So let me draw the next one just to make sure you're on the right track, and then I've got some for you to practice. So again, if you get stuck on these, let me know, because they can be a little bit tricky. All right, so let's see here. So let me move this one over a little bit. Let me draw it in black. So I'm going to start here at 0. All right. So again, in this case, what I've got is I've got -6 minus 2. So again, what I'm looking for is what number added to -2 or actually added to, oops, sorry, hold on. It's not -2, it's +2. Let me erase that. I was looking at the subtraction sign. What number added to +2 will give me -6 as an answer. So again, first step is we want to draw our answer first. So in this case, we want to draw a big arrow going from 0 back to -6. And so in this case, what we're going to do is we're subtracting positive 2. So when we draw our little red arrow this time, so again, we want our tip to start here at -6. So what's going to happen is it's actually going to go this way. It's going to go backwards. So in this case, my 2 is going to go over to the left, because what number do I need to add to 2 to get -6? Well, I need to add -8 in this case. So if I take -6 and then jump 2 to the right, so this is my +2, then that's going to land me at -6. So since I'm kind of adding 2, that's why I jumped in that direction. So same way we added 2 here, so we technically jumped in the same direction. It's just backwards looking because of the way the -6 is looking. And so that gives us our final answer of -8. So trust me, these number lines can be a little bit tricky. So if you get confused, or if you want to see like practice 4 written out, just let me know. I'll write the answers out and post them for you so you can see what they look like. But if you keep practicing, they get... So in this case, so what I've got is, so go ahead and work on practice 4. If you have any questions or anything about practice 4, just let me know. And then here's a little word problem, practice 5. So again, you can use kind of any model you want on these. So if you want to use the number line, feel free to use the number line. If you want to use the colored counters, use the colored counters. So either way, just let me know if you have any questions or anything. Otherwise, when you're done with that, come on back and we'll be ready for video 5.3.